I'm gonna go from Humboldt Bay to the California Current because that is the system that lies off our coast. We have, as Troy pointed out, and my group has brutally experienced, a very important part of the windiest part of the California Current. But I'm going to give you a sense of what that context is and how it comes into Humboldt Bay a little bit here. I'd like to acknowledge first two of the folks here that have contributed data to this. Roxanne Robertson, who's in the audience, has done tremendous work helping lead this project and doing the krill work. And Blair Winnicott is a former graduate student who did really nice work on the larval fish that I'll be presenting. Before I start, and I will show this slide at the end, I want to point out there are really good useful resources for looking at the California Current as a whole and getting an idea of how this system is responding to large-scale climate forcing and large-scale climate change. Like I said, I'll put this up there. I'm going to be drawing from some of this to provide this context. Okay, so you're going to hear me, you heard me just say climate forcing and climate change, okay? And there are two things going on here. One is we have large scale, those systems that Troy was talking about, they vary year to year, decade to decade, and they set up really big changes in the structure of the North Pacific Ocean and the California Current, which is part of that affect our system. We have, I hope my slide, yeah, it's coming up there. A number of indices. This index, these are numerical digests of, say, sea surface pressure or sea level pressure, sea surface temperature, things like that. This is the El Nino index. Right now, here you can see the triple El Nino that was just mentioned. This is an index called the Pacific Decadal Oscillation that lets us know is flow more strong in the California Current versus the Alaskan Current, the Alaskan gyre. The North Pacific Gyre Oscillation tells us the relative strength of both of those gyres. Right here, we've gone through a period of negative NPGO, positive PDO. That meant the California Current was actually flowing pretty slowly relative to its normal, its mean. This next slide here is the temperature of the North Pacific as a whole. And you will notice that it has been getting warmer and warmer and warmer. That's the climate change. We have the climate forcing, the changes in these pressure systems, and then climate change is happening on top of that. Here's the California Current temperature, and you see that we are being somewhat protected from this ongoing heating of the North Pacific. That's in part because of the upwelling that Troy was talking about, and in part, well, mostly because of that. But I want to talk about the system here is changing. Okay, we have this warming, we have the marine heat waves we've encountered, things like that. If we look at the El Nino, this is a sea surface temperature anomaly. Is it relatively cooler where it's blue or relatively warmer where it's orange for that particular location in the ocean? North America right here. And this is the typical La Nina pattern. Cool water all the way along the coast. A little bit of warmer water out in the North Pacific, okay? That's what it's looked like for the last 10 El Ninos before we got to this one, what's happening during our current rapid heating phase. You'll see that we're not seeing that same cooling. We see the same pattern, but the whole system is warmer. And so I point this out because when we think about, oh, it's a La Nina, well, La Ninas are changing in what they mean. Circulation's kind of the same, temperatures are not. And so we got some things to be thinking about when we're thinking about climate change and how our system is responding. This has set up some really unusual patterns, unusual patterns in the ecosystem that we have anchovies occurring, booming in warm water. That's atypical. Persistent pyrosomes. I'll show you a picture of one of these. It's a weird zooplankton thing. Looks like a cucumber that floats out in the ocean. These weird and unusual juxtapositions of warm and cool water ecosystems that are causing we fisheries oceanographers some head scratching, like what's going on, what are the implications for the ecosystem. I'm going to be focusing on the Trinidad headline. That box gives you the period of time that we'll be talking about there, 2008 to the present. And this is the Trinidad headline. For those of you who don't know, if you've been to these before, you've probably seen this slide because it's my favorite slide of this system. We were established in 2007 in the middle of a gigantic gap in year-round observations. We go out monthly. We We do these snapshots of the coastal ecosystem. We're in a really dynamic region here between the two capes. And we go from a couple stations on the shelf to a couple stations off the shelf. And we try to, like I said, do this about every month to take snapshots of what the coastal ecosystem looks like. And it feeds into these ecosystem assessments. We're part of a big, big enterprise coastwide. You all know that's an important place, not just because of the bay. It's the home both for early marine life and the returning adults of Chinook salmon, from the Klamath in particular, and the eel. We have been identified as potential hotspots for harmful algal blooms and exposures to ocean acidification and hypoxia. So these are all things, dynamics that we're worried about. So what do we do out there? Really quickly, this is another former graduate student right here, Natasha, who helping sample water out of our CTD, or conductivity temperature depth sensor, which helps us measure the structure of the ocean. This is, say, the temperature from near shore going to offshore by depth. And if we take these sections and we put them together and say we take a slice right here and we stack them up over time, we can see that the temperature changes seasonally. We can see the marine heat wave happening here. This is chlorophyll. We can see those massive harmful algal blooms that affected the coast and the crab fishery in particular during 2015. We complement these physical and chemical observations with a collection of zooplankton, particularly look at krill, copepods, and larval fish. Now, I'm not going to get really deep into a whole lot of data. I just want to kind of give you some general patterns of what we've been finding. And you can go to these resources to see this in broader context. Oh, actually, I forgot something. We're going to be augmenting this with these really fancy tools called gliders. These autonomous vehicles, we drop them in the water and they're able to change their buoyancy. And with the wings, they're able to fly forward. They're able to come back up and do these undulating sections and go out there when it's windy, sample, return the data to us, and I don't have to throw up. It's pretty awesome. So they don't get us everything, but they're going to get us a lot. And it's really going to complement what we're doing on the Trinidad headline. So more on that at the next Humboldt Bay Symposium, I hope. So back to, we have these data that we're collecting. Some of the general patterns that we're seeing. The marine heat waves and El Nino, these warming events, drive shifts in the zooplankton. This is the base of the food chain. This is what the salmon are trying to eat. This is what the rockfish are trying to eat. This is what the seabirds are trying to eat. These are a number of, I'm not going to go into a whole lot of detail, but the distribution of a whole slew of different krill species. And where you see the blue ones, these are cool water species, tend to be associated with cool water conditions. The red being where the, and apologies to anybody who's colorblind, I got to fix this. Tend to be warm water species or offshore species that come in when warm water presses up against the coast. And during the marine heat wave, we saw massive transitions between cool water species being displaced, warm water species coming in. This has implications, we saw this in copepods as well. This has implications for the food web because warm water species tend to be lipid poor. Cool water species tend to be very energetically rich, and so it changes the base of the food chain. A couple rare species that come in, these species, Nyctiphys simplex, that's typically off Southern California, but when we get these big pushes of water out of the south during El Ninos and during the marine heat wave, they get pushed into our area. Euphausia recurva, normally hundreds of kilometers offshore, getting pushed in. We're able to see the physics driving changes in the structure of the ecosystem. Just a quick update where we are during that La Nina, the triple La Nina. It got cooler. We're not seeing a huge recovery, but we're also seeing the cool water sort of coming back and the krill coming back. This is preliminary because we're still digging through a backlog of samples. But I will remind you that our La Ninas have been warm La Ninas, which is not normal. And so we're thinking that there's going to be some persistent changes here. One of those persistent changes, these are the pyrosomes. These are relatively large specimens. When the marine heat wave came in, there was a massive bloom of these things all up and down the coast. In our area, it seems that they are persisting, and it may be because of the circulation around the capes and things like that. They're not seeing them so much off Newport, Oregon anymore, or to the south. We're still getting them, although they're pretty small. These alter carbon flows and all sorts of things in the ecosystem. Another general pattern that we're seeing is just as the zooplankton are changing, we are seeing changes in the larval fish and larval cephalopod, particularly market squid assemblages. And we think these actually reflect, thank you, reflect temporary changes in adult populations. Yep. The adult fish actually moved up. People caught croaker off Trinidad Head. Those are a southern fish, and there were larval croaker in the plankton. Short-belly rockfish moved up. Market squid moved up. Things like anchovy showed up when we had this warm water. So we see these large-scale shifts occurring when we see the climate forcing. We can expect to see these possibly progressing as climate change goes forward. And then I did mention a lot of work done by Roxanne on krill. We've had a really nice study showing that krill size is inversely related to temperature. Just for example, this is a big female Euphausia pacifica in 2013. And right after the marine heat wave came in, they were all small. You can imagine what that's like if you're a salmon out there looking for food. And it turns out that there is a really nice relationship between the difference in length over the course of the summer and returns to the Klamath River. So we're thinking that this might actually be capturing and integrating the physical effects into ecosystem effects into something that we really care about, like salmon to the Klamath. I just want to step back to the bigger picture, okay, and just give you some kind of takeaways. First of all, North Pacific is warming. Climate-environment relationships that we may have understood in the past, that PDO or the Pacific Decadal Oscillation in a certain phase leads to a productive environment. A La Nina leads to a certain environment. Those things are looks like it's being disrupted. If you read the references that I was talking about, there's some concern in our community that what we thought used to happen, the rules are changing because of warming, okay? But I want to point out that we are really valued in this system too, in its entire enterprise. Regional observations such as those from the Trinidad headline, we resolve the local changes. We see what's going on in the ocean around the systems and around the communities that we're interested in and help us see the big picture. That's where that California Current Integrated Ecosystem Assessment and our contributions play out. And as I didn't really get into with the krill, we do see some of these changes appear to be shifting back. Cool water krill back in the system, becoming a little more dominant. Some of these things like the pyrosomes are sticking around. So that may be a relatively persistent perturbation to our coastal ecosystem. I want to really quickly thank everybody. We've had 100, 150 undergraduates help us out on this. The Coral Sea has been a big help. I do want to say thanks to Frank. He was one of the first colleagues here that welcomed me when I came in and got me involved in Senkus and all that stuff. So he's never been out on the ship. But then again, I've never been out on the mudflat. So we just enjoy each other's company. And I'll just put this up as useful resources in case you didn't get to see it before. And thank you for your attention.